Hi, this week's challenge was to build a circuit that included two specific components, one being a motor and the other being some kind of sensor. And what I decided to use for my specific circuit was an LDR, which you can see right there. That's a light dependent resistor, which is another kind of name for it. It would be like a photo sensor. And then as my motor, or an application for my motor, I attached a plastic fan head to this that I had laying around the lab, and that will make the motor serve as a fan when it's turned on. This circuit was challenging for a couple reasons. One reason was just figuring out how to connect these two components. And when I say two components, what I mean is the circuitry needed for the LDR, the light dependent resistor, and then the circuitry needed for the motor. The circuitry needed for the LDR was not too terribly difficult. You need to use a 10K ohm resistor, which is right there, and you have to connect it to an analog pin right back here. Okay, the part that was kind of tricky and took a lot of learning was how to connect the motor. Now the motor is an electrical component that I have cased in this binder clip jar that's just plastic. I needed some way to hold the motor up because the amount of current or voltage that this motor is receiving or can receive is not enough to turn the turbine if it's laying on its side with its weight holding it down. So the torque would not be great enough in that case. Now what you need to do is, because these fans do not have, or the motors do not receive enough current, what you end up having to use is this little guy right here, which is a transistor. And a transistor is a semiconductor that sort of acts as like a switch or an amplifier, and it can amplify current and voltage and then switch or switch on or off, or act sort of as some sort of a gate. And what that's going to do is actually amplify and allow enough current voltage to run the motor. The other thing that you need to end up using when you do this construction of a fan, or in this case a fan but a motor, is this little thing right here, which is a diode. Now inside a fan, you can see the diode again right over there. Inside a fan, there is a coil of wire and a magnet, and without getting too far into the details, when the motor is turning off and the current is dying, there's something called magnetic flux, which starts to decrease. And if it starts to decrease, the natural tendency is for it, the coil of wire to respond by preventing the decrease. And it's just kind of like a push and pull conservation of energy phenomenon that I'm not going to get into here. But the reason I'm bringing that up is because the diode is needed in this case, because when this starts to die down, the current pushes back in the opposite way, and then that can push against the direction of flow in the circuit, which can cause some other issues. So I'm going to just turn the computer on here. The code is all in my in the blog. I wanted to be able to show you this. I'm not going to really focus on the code in this video, but basically what I did was I built an LED LDR circuit. So right here where all this is, there was just an LED before that I built in a previous circuit. And if I cover the LDR right here, then I would generate a current which would make the light turn on. So I replaced the light with all the circuitry for the motor, so that when the sensor is covered, the motor turns on. So let's cover the sensor, and then you can see there it turns on. Now what's interesting is, depending on how much it's covered, it will spin faster or slower. So if I take my hand and I completely block out the light, you can see that spinning a whole lot faster than if I just used this little screwdriver to partially block the light. Not even enough sometimes to get it going. But that is the circuit for this week, and I hope that is interesting to you. It's a pretty neat circuit.